Hello and welcome to this introductory video on Unified Learning Kit. This video is prepared by the ULK team of Mission 10X, Wipro Technologies, Bangalore. In this video, we are going to talk about evolution of ULK. With the current situation of employment in India, industry and academic institutions speak out their concern on the limitations of engineering education in the country. We also conducted a survey on the employability skills of engineering graduates. The survey enabled us in identification of the gaps between skills perceived by academia and the skills sought by the industry. The skill gap analysis made way for the development of Unified Learning Kits by Mission 10X. We are also going to look at the idea behind the ULK and how it helps in filling the skill gap. ULK is a learning framework and ULK-1 is the current product under the ULK umbrella. We will also talk about future plans of ULK. When we talk about employment, it is very important to understand what it means in the Indian context. What are the skills that would improve the employability potential of engineering graduates? And that comes from what industry is looking for. Are we really focusing at those primary skills sought after by industries at our institutions? The need of the hour is to enhance our education in such a way that it leads to employability of the students. Let's have a look at some of the numbers that describe the status of education and employment in the country. Nationally, an average of 350 students per million people enter the technical degree program, and over 3 million graduates and postgraduates are produced yearly by our colleges. However, as revealed by many surveys, only 26% of them are considered as employable by the multinational companies. In fact, more than 60% of the employers are not happy with the skills possessed by these young graduates. They end up spending time, effort and money in training them after hire. In recently conducted survey, both industry and academia aired their concerns with the education system. Jaswinder Ahuja, VP and MD of Cadence Design Systems, says,
University education in developed countries is industry-oriented and one that emphasizes practical training, as opposed to a largely theory-focused system followed in Indian engineering colleges. Avenues that provide real-time access to real-life work situations for students, such as internship and apprenticeship, should be an integral part of the curriculum.
Other MNCs agree to this. Mr. T.V. Prasad from Cyprus Semiconductors feels that Tier 2 and Tier 3 colleges have systems that churns out graduates who are not application-oriented and learn concepts by rote. The demand for well-trained engineers in design, services and manufacturing companies is very high, and we are not able to produce that many skilled workforces at colleges. Academia also feels of the need of enhancing the education system. Mr. Vedula, Dean of a renowned engineering college, quotes,
Engineering education needs to pay more attention to the development of innovation, entrepreneurship and ability of the graduates to function in a constantly changing global environment. India has a large number of youth with strong math and science skills interested in engineering careers, but limited by inadequately trained faculties, poor facilities and limited research in a majority of engineering colleges.
The syllabi are more oriented towards the theoretical aspects, and the focus is on covering a wide range of topics with preset, archaic and low technology based lab work. So what is employability? How is it perceived by different stakeholders? What are the skills that engineering graduates require for being employable? From a recently conducted survey, we have highlighted the key skills that lead to improved employability potential. Skills like hands-on experience, problem-solving skills, entrepreneurship, industrial application of engineering and technology, and flexibility are looked upon by employers. Employers still feel the gap between skills they look for and skills possessed by graduates. Why do they lack the employability skills? The skills can be attributed to students have constrained scope for fostering innovation due to the limitation in learning environment. Multidisciplinary and customer-centric product development approach practiced at industries is not part of the curriculum at most of the academic institutions. Many of the lab equipments used for reinforcing theoretical concepts need to be scaled to the current levels used in the industry. Lack of integrated learning through multiple course offerings. Lack of hands-on knowledge and exposure to modern technology becomes a barrier for employment. Industry needs to spend a lot of time, effort and money in training the fresh graduate employees till they become productive for the organization. The key reasons for the skill gap appears to be lack of hands-on exposure on latest tools, unfamiliarity with multidisciplinary system design approach, and application of technology in real life. Mission 10X devised an innovative learning framework to bridge the technology gap. ULK framework focuses on incorporating the best practices followed by engineering institutions in developed countries. For example, advocating industry-focused syllabus, abreast of technological advancement, focus on practice-based learning, industrial training, research, problem-solving skill development, collaboration with industries and encouragement for entrepreneurial mindset. In a nutshell, the education system should focus on quality rather than quantity. Before talking further on ULK, I would like to brief you about Mission 10X. Mission 10X is a not-for-profit initiative of Wipro Technologies to improve the quality of engineering education in the country. Mission 10X aims at empowering the engineering faculty with innovative pedagogy techniques so that they ensure active learning happens in the classroom. Engineering faculty members get trained to go beyond the conventional teaching practices and experiment with innovative learning techniques and tools like the ULK that ensure active participation of students in learning of engineering concepts and its real-life applications. So what is the idea behind ULK? ULK is developed to inculcate practice-based learning of engineering concepts. It integrates learning of multiple subjects and hence ensures maximum utilization of learning kits. It exposes the students to the cutting-edge technology that industry is working on, thus helping the students to be industry ready. It also teaches product or system design approach. The slide lists some of the key advantages of ULK. It helps the students relate the engineering concept with real-life application, makes the student ready for industry by exposing them to technologies industry is working on. This unified learning approach is easily extensible to other domains as well. It provides a platform for the students to get hands-on experience in embedded system design, embedded Linux, digital design, ARM, DSP, FPGA programming, and product design. Once they become familiar with ULK, they can also build their final year project around it. The Unified Integrated Framework ensures that ULK can be used for multiple subjects. It enables holistic learning and encourages students to take up product design assignments. So what does the ULK team have in the offering? We have the first product ULK-1 being shipped to selected institutions and working on design of other kits. In the video, we are going to briefly describe the ULK-1. ULK-1 is an advanced programmable kit for students of electronics, digital technology, and embedded system design domains. ULK-1 covers multiple subjects of electrical engineering, electronics and communication engineering, electronic instrumentation, and computer science branches. It is an all-in-one solution capable of accommodating the lab experiments of subjects like VLSI, embedded systems, control systems, digital signal processing, digital electronics, computer programming, microcontrollers and microprocessors. In ULK, we advocate the use of open source technologies and components. It consists of OMAP 3530 processor which has ARM and DSP on the same chip. You would find this processor on many of the Nokia smartphones as well. The kit also has an FPGA from Xilinx. It offers use of components of the kit which are FPGA, DSP and ARM processor in a selective or combinatorial fashion for building next generation real-life applications. This is how the ULK-1 looks physically. As we see, it also includes an LCD touchscreen and different industry standard interfaces. Further details of ULK-1 are available in a separate video. To complement the innovation ULK brings in, we also have come up with an innovative experimental framework. This is an enhanced workbook template developed by Pedagogy Research Team of Mission 10X. The workbook divides each lab exercise in pre-lab, in-lab and post-lab components to maximize the learning. The exercises provided in each section also helps a teacher in assessing the effectiveness of lab exercises. After launching ULK-1, the ULK team is currently working on the design of kits in other areas like robotics to provide a platform for mechatronic and control system learning, non-IT kits for non-computer science subjects like electrical engineering, biomedical engineering, and so on. The ULK team is working on collaboration with IIT Bombay on a small but innovative embedded system kit for control system concepts. We are also looking at simulated development which can impart active learning to the student. With this, we come to the end of the video. At Mission 10X, ULK has evolved to fill the technology gap between academia and industry. ULK brings the students on the same platform and as industry is looking them to be. ULK-1 was launched in December 2010 and we are looking forward to the development of learning aids in other areas as well. Thank you for watching this video. For more information, please visit the Mission 10X portal.